Have you ever worried about what happens when a critical server unexpectedly stops working, potentially bringing your entire system to a halt and leaving your users frustrated or even worse, unable to access essential services? Active-passive software redundancy is a widely used strategy in system design where you have two identical instances of a service or application running, but only one is actively processing requests at any given time, while the other remains on standby, ready to take over if the primary fails. The core idea behind active-passive redundancy is to ensure continuous operation and high availability, even if a primary component encounters an issue. Think of it like having a primary and a backup generator for a hospital. The primary generator runs, providing power, while the backup sits idle but fully functional, constantly monitoring the primary. In a software context, the active instance handles all incoming client requests, performing its designated tasks. Meanwhile, the passive instance continuously monitors the active one, often through a mechanism called a heartbeat. This heartbeat is a periodic signal sent by the active instance to confirm its operational status. If the passive instance detects that the heartbeat has stopped, or that the active instance is otherwise unresponsive, it initiates a failover process. During a failover, the passive instance transitions into the active role, takes over processing new requests, and ideally, restores any necessary state from the failed primary. This setup means that while one instance is performing the work, the other is ready to step in at a moment's notice, minimizing downtime. A crucial aspect of this design is ensuring that the passive instance has access to the most up-to-date data. This often involves real-time data replication from the active to the passive server. The success of an active-passive system is often measured by its recovery point objective, which is the maximum acceptable amount of data loss measured in time, and its recovery time objective, which is the target time within which a business process must be restored after a disaster to avoid unacceptable consequences. Implementing an active-passive setup involves careful planning. You will need to select robust monitoring tools to accurately detect failures and establish reliable data replication strategies to keep your passive instance synchronized with the active one. For stateful applications, ensuring consistent data across instances is paramount. Regular testing of your failover procedures is also essential to confirm that your system can indeed switch over smoothly and efficiently when a real failure occurs. One of the key benefits of active-passive redundancy, especially when compared to active-active configurations where both instances process requests simultaneously, is its relative simplicity in managing data consistency. Since only one instance is writing data at a time, you avoid many complex synchronization issues that can arise in distributed systems. This makes active-passive a common choice for critical components like primary database servers, certain firewall setups, and application servers that hold significant session state. By strategically deploying active-passive redundancy, you are building resilience into your software architecture, directly protecting your operations from unexpected outages. It is a fundamental strategy for maintaining service availability and ensuring your applications remain as reliably accessible to users, contributing significantly to a robust and stable system.
If this helps you code smarter, like, subscribe, and stay tuned for more.